my name is Jackson,
And I'm Nathan.
and first we tried to make a stepper motor walking robot.
But through trial and error, we found it wasn't going to work, so we ended up making it something different. So the original design was going to have 4 stepper motors attached. One attached here and one attached here on both sides. And it was supposed to turn this up, rotate forward, extend, and walk like that, and do the opposite thing on the other side, fully supporting itself and supported by wheels on the back, which had some nice wheels for it. But that didn't work.
The problem was the stepper motors didn't have enough torque to lift themselves up, let alone lift 2 of them up. So realistically, it was never going to be able to support itself. We did try referencing the datasheet and switching the motor current jumpers. Using those, you can switch from 1 amp to 2 amps all the way up to 6 amps, which should increase the torque output, but nonetheless, it still didn't work. At this point, we realized that our original design wasn't going to work, so we were going to have to come up with something else. Only we had put in a lot of work building what we had so far and didn't want to just throw it all away. So we spent a lot of time trying to think of how we could get it to walk without having to support itself. In the end, we decided it would be best to make the legs completely round, like wheels.
Alright, moving forward.
If we had shorter legs in the back, it would turn a lot easier too.
Yeah.
Yeah, that thing is hauling now.
Yeah.
And here's our virtual instrument that controls everything about our robot. There are 5 cases in this case structure, one to move forwards, backwards, turn to the right, turn to the left, and then the 5th one is to be in park. And we also have a second DAC assistant which control the lights, which turn off if it's moving forwards. And we have a light on the left for when it's turning to the left, and a light on the right for when it's turning to the right. We also have both lights on when it's in park. And then on our front panel, we have 4 buttons that control to move forward, backwards, left, and right.
So to make it easier and more fun to control, we decided that we wanted to be able to control it with an Xbox controller. To do that, we mapped our control buttons to keys on the keyboard. Then we used a program called Joy2Key to map the keys to controls on an Xbox controller.